Okay, so conditional probability is this bit here, okay, where we can find the conditional probability, the probability of one thing happening given another, and it's A intersection B all over B. So if it's find the probability, normally it's written in this notation here, X slash Y, and that's the probability of X given Y. So it's kind of more of a straight line. And that means we employ this formula here, which is the probability of X intersection Y all over the probability of Y. Okay. So I am on page 67, I think, of your books, and we're looking at question 2. Okay, so the first part of this question says, 2 fair-sided dice are rolled. For A to satisfy, the total is over 8. For B to satisfy, at least one die shows over 6. So before we get into any of these questions here, what I need you to do here is do me a sample space or a two-way table showing me this information here. And then we'll come back and we'll do these questions together. So I'll give you a minute or a few minutes to do that. Okay, so as you can see here, I've done a quick sample space or a two-way table. So 2 fair 6-sided dice are rolled. The first, I suppose, event is that the total is over 8. So let's have a look there now and see how many of these would the total be over 8. So over 8 means I need to get 9. So just this one here, might do it in yellow. And 9, 10, 9, 10, 11, 9, 10, 11, 12. Okay, so for A to happen, you can get a 3 and a 6, 4 and 6, 5 and 6, 5 and 4, mistaken that one, 5 and 5, 6 and 3, 6 and 4, 6 and 5, and 6 and 6. So let's count those. 1, 2, 3, 4, 5, 6, 7, 8, 9. Are we happy with that? Am I missing one, I think? I think I don't have 4, 5 written down. Do you see that? I just don't have 4, 5 written down, so let's write that one down. Okay, so there's 10 options there. Okay, so the next one I want you to do yourself. So the probability of B, at least one die shows a 6. So off you go, write down those ones. All right, so are we happy with all of the ones I've underlined in green as ones that satisfy that? So I suppose I'm going to write them down. So 6 and 1. Okay, and we obviously don't write the 6 and 6 again. Okay, so far what we've done is we have looked at the question and we've written out the event A and then the event B that satisfies event B. So the next question, it says, list A intersection B. So what if A and B happen together? All right, okay. So the probability of A intersection B happening, they both have a 3, 6, 4, 6, 5, 6, and 6 and 3, 6 and 4, 6 and 5, and a 6 and 7. Okay, so there are 7 chances of that happening. Okay, and I think we have to list them. So you'd just be saying A intersection B is equal to, and you would write down all of the ones I've circled there. Okay, so then we move on to part B, and part B says the probability of B slash A. Okay, so what words are we using to describe this? So this is the probability of B happening given A happening. That's the conditional probability, and we have a formula for that. It is the probability of B intersection A, or A intersection B, whichever, all over the probability of the second one happening, which is A. Okay, so the probability of B intersection A is the same as the probability of A intersection B. It's the same thing. And we know for this one, we have 1, 2, 3, 4, 5, 6, we have 7 answers. All over the probability of A happening, well, we worked it out here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the answer to that is 7 out of 10. The next one, I want you to do it now yourselves. The probability of A happening given B happening. Hopefully we have the answer. The probability of A intersection B all over the probability of B happening. So A intersection B is still 7. The probability of B, when we check that, there's 11 answers. So 7 over 11 is your answer there. All right, okay. So let's have a look at our next question. Okay, a family has 3 children. Complete the outcome space, okay, where GGB means the first 2 are girls and B means boys. So if they're in that order, that's what it means. So we're asked some questions on it, but the first thing I want you to do is I want you to write out all the solutions. Now, how many solutions is there? How do I know I'm finished? Well, you could go back to the choices. So if you have a baby, you have a choice of it being a girl or a boy. So the first child could be a girl or a boy. Isn't that right? Then you have another baby, and the second child could be a girl or a boy. And then you have a third baby, and the third child could be a girl or a boy. So that will tell us how many outcomes there are. There's 2 in the first instance, 2 in the second instance, 2 in the third. 2 by 2 by 2 is going to give me 8. So I need everybody to write me out 8 answers. Off you go. Okay, so I've written a few out here. So there are 8, and hopefully you got all 8. So now we have to do some questions. Find the probability that all 3 children are girls, given that the family has at least 2 girls. So let's write it in notation first. That basically means the probability that all 3 are girls, so you have all girls, given that there are at least 2 girls. Okay. Okay, so we go back to the probability of A given B is the probability of A intersection B all over the probability of B. Okay, so these 2 intersected. What does that mean? Okay, so what it means is the probability that you have all girls intersecting with 2 girls, oops, G-R-L-S, yep, all over the fact that you have at least 2 girls. Now, the probability that you have 3 girls intersecting with 2 girls, where will that happen? Where it'll satisfy both of those. That you're all 3 and you have 2 girls, at least 2 girls. Okay, it's only this one here, right? So what's the probability of that happening? The probability of that happening is 1 out of 8. Okay, all over the probability that you have at least 2 girls. Well, how much is that? At least 2 girls. Well, that one's fine. That one's fine. That one's fine. And then obviously this one is fine as well, isn't it? So that's actually 4 out of 8. Okay, and you just type that into your calculator. Some people will write it as decimals, so 0.125 all over 0.5. And you type that into your calculator and you get 0.25. Okay, so again, I've just filled out a table here, putting all of this information into it, super important. And now I'm going to turn it into probabilities. So the probability of a boy who plays hockey would be 50 over the total, which is equal to 0.2. So I can now go about filling out all of these probabilities. Okay, so the next one will be 0.2 here again, 0.48, 0.12, and then you've got your totals. So the total amount who play hockey is 0.68. The total amount who don't play hockey is 0.32. And then the total amount of probabilities are boys, 0.4, 0.6, and of course they always have to add up to 1. So going to just move a little bit quicker now. So find the probability if that a student is a girl given that the student plays hockey. So the probability that it is a girl given that the student plays hockey. So that is the probability that you are a girl and you play hockey all over the probability that you play hockey. So we have it all done now, all the hard work, okay? So it was kind of taking that information, putting it into a table, then finding the probabilities. So we are going to have the probability that you are a girl and you play hockey. I have it there circled in blue. So it's 0.48 all over the probability that you play hockey, which is 0.68. You can break that down a little bit further. The next question says, find the probability that you play hockey. So just let me play hockey given that you are a girl. Okay. Oh, hearing myself there. So that's going to be the probability that you play hockey altogether is 0.68 all over the probability that you are a girl. Sorry, it's just that you are a girl that plays hockey. So it's 0.48 all over the probability that you are a girl, which is 0.6. Okay, and you can break that down to 0.8. So I know I'm rushed the last bit here, but the Zoom is just about to end, so I didn't want to miss it. So look, that's a couple of questions on conditional probability. I'm going to give you some now to do. I'll write them up now to get them done for me for today. All right, so I know I sprung this Zoom on you a little bit quick, so I have recorded it for anybody who's missed it, all right? This is just the last question that we didn't get to do in class, but just to look at it here, it says, if A is a subset of B, proves that the probability, or find the probability of B given A. So A is a subset of B, so I suppose visually let's represent that. So here is A, and this is B. Okay, so A is a subset, so it fits inside B. Prove that the probability of B given A is equal to 1. Do we know the probability of A, the probability of B? Because the probability of B given A is equal to the probability of B intersection A. I'll just make that a bit cleaner. B intersection A all over the probability of A. Do we know the probability of A? No, but so anything we don't know, we call it X. The probability of B, so I'm going to call this X. Well, the probability of B, obviously X is inside B, so I'm going to call that X again. Now, the probability of A intersection B, so the probability of that happening would only be this bit here, wouldn't it? A intersection B is the bit in A that's in B, so that would be X all over the probability of A, which we know is X, and we're going to get 1 there. So that's just the last one that we didn't get a chance to do. So you can see here the probability of A we don't know is X. The probability of B, we can call it X, we can call it Y, okay? But you can see here the probability of B intersection A is going to just be X. And then the probability of A, so X over X equals 1. That was just the last one we didn't get done today.